All right, welcome back. Here is your final lesson of 2020 in math, and this is going to be like our practice test for your test later today. Question number 1. Solve for the missing side, round your answer to the nearest tenth, just means 1 decimal place. So you have to decide which tool out of your toolbox to use. You take a look at your triangle, you see that little square for 90. Automatically, hopefully that should signal to you to write down these 3 words. Step number 1, circle your reference angle. 90 can never be your reference angle, so the only other angle I gave you was 63. Label your sides across from the 90, hypotenuse, from your reference angle. All the way across is your opposite, and right beside is your adjacent. Now, when you are deciding which one to use out of Sohcahtoa, which side gives you nothing? There's no number or there's no letter. That would be the adjacent, so let's scratch that out. And all we're left with is O and H. O and H is only in So. S stands for sine. Always beside these go the angle you circled. So sine 63, and they go in order. O then H, O over H. X over 15. And how do you get that x by itself? In other words, how do you get the 15 off the bottom? Cross multiply. 15 sine 63 equals x. Take out your calculator. We're going to go to 1 decimal place, type it in just like you see it. 15 sine 63. And hopefully you got 13.4 in this case meters. And as a quick self-check, it doesn't tell us we're right exactly, but if we compare that to the hypotenuse, which we know is supposed to be the longest, since that's less than 15, we can safely assume that we're on the right track with that. Number 2, solve for missing angle Q and round to the nearest degree, which just means nearest whole number. Step number 1, take a look. Do you see the 90? Yes. So we're going to write down Sohcahtoa. Circle your reference angle, which can never be 90. And in this case, your reference angle, it can't be 90. The only other angle that you could possibly circle is the one you're looking for. So that's angle Q. Label your sides with respect to Q. So across from the 90, hypotenuse. All the way across is your opposite. And then right beside is your adjacent. Now, which side gives you nothing? That would be opposite, so get rid of it. That tells us that we have A and H, and the only one that has A and H in it is Ka, and the C stands for cos. What you circled, which is Q, goes in order, A then H. So adjacent, which is 20, over hypotenuse, which is 25. Don't type in cos 20 divided by 25. Remember, when you're looking for an angle, you are going to use the inverse, so the shift or second function button. So Q equals, now I caught myself there, and that's a common mistake. We get so used to using sine. Q equals cos inverse, and then 20 over 25. And you type that into your calculator just like you see it. Shift cos, bracket, 20 divided by 25. You want to go to the nearest whole number. So I get, when I round, 37 degrees. So there's 2 primary trig, Sohcahtoa review questions. Question number 3. We're going to use a diagram, fill in the information. We want to find side length B. And we have to fill in all that information for angle A, angle C, and side A. Now you can fill this in however you want. So we're consistent for our lesson. I'm going to call that A, B, and C, which makes that side B, that side A, and that side C. Then let's fill in what we're given. Angle A is 82. Angle C is 68. And side A is 15. And we want to know side B. I don't see a 90 in there. So we're not going to use Sohcahtoa. So we're going to go to our chart. Fill in what you know. A is 82. C is 68. And side A is 15. And we want to know this. So you're going to ask yourself, do you have a complete letter? The answer is yes. A is complete. So that's our cue to use sine law. However, in this case, we don't have angle B. And to be able to solve for B, right, B over sine capital B, I don't have capital B. However, we have an easy way to get that. If you have two angles, remember there's 180 in a triangle. Sorry, I don't know why the pen keeps doing that. Just have to live with it. 180 minus 82 minus 68. So when you use your calculator, 180 minus 82 minus 68 gives you 30. So we know B is 30. Now we can complete our sine law. B over sine 30 equals what you drew the box around, which in this case 15 over sine 82. Get that sine 30 off the bottom by cross multiplying. So B equals, sorry, didn't mean to put that divide line in. So B equals 15 sine 30 over sine 82. Type that in just like you see it. 15 sine 30 divided by sine 82. And we'll say go to one decimal place. 7.6 centimeters. And there is side B. Number 4, find the length of angle A, and we're going to fill in all this information. Again, doesn't matter for a test what all of these are, but let's just label it like that. Side A, side B, side C. Fill in all our info. A is 7 centimeters, C is 4, and angle C is 32. And we want to know angle A. Now I don't see a 90, so we're going to go to our chart. A is 7 centimeters, C is 4 centimeters, capital C is 32, and I'm looking for that. Since there's no 90, no Sohcahtoa, do we have a complete letter? Yes, C, that's our indicator to use sine law. So this time we're using sine law for an angle. sine A on top over A, which is 7, what you drew the box around, sine 32 over 4, cross multiply, sine A equals 7, sorry, that's getting annoying, sine 32 over 4. And remember, when you're looking for an angle, you don't just type that in with a sine. You got to do sine inverse. 7 sine 32 over 4 in brackets. So shift or second function, sine open bracket, 7 sine 32 divided by 4. And we'll go to one decimal place again, which in this case, if we round, it actually gives us the nearest whole number, which is 68 degrees. Moving on to number 5, and basically the rest of these are all going to be word problems. A golfer hit her tee shot so that it landed 6 yards behind a 36-foot tall tree. Right off the bat, we have a little bit of an issue, which we'll take care of in a second. But we got yards mixed with feet. That's not good. She decided to take her second shot, hoped the ball would make it over the top of the tree. She used her lob wedge, hit the ball, sending it upward at an angle of 55. Was she able to clear the top of the tree? And I've given you the conversion here. There's 3 feet in a yard. So we know we're going to make a triangle here. I've already started it for you. And she's going to hit the ball and try to make it over the tree. And we have, she's 6 yards behind the tree, and the tree is 36 feet tall. So this is 36 feet. Now we have to do a simple conversion here. And there's 2 ways to do this. You could convert feet to yards or yards to feet. I'm going to convert yards to feet. And since there are 3 feet in 1 yard, if I have 6 yards, if I do 6 times 3, that gives me 18 feet. Now there are multiple ways to figure this out. You could put 55 in there as the angle of elevation and see how high the ball would go. Or you could figure out what the angle of elevation needed is to actually get to the top of the tree. It doesn't matter which one you pick. I'm actually going to pick to find the angle just to get more practice with finding angles. Since it's 90, again, we can assume that a tree meets the ground at 90, unless I tell you otherwise. Since there's 90, we're going to use Sohcahtoa. Circle your reference angle, which never your 90. The only other angle you have is the one you're looking for, which is x. So we're going to circle that. Label your sides. Across from the 90 is hypotenuse. Across, so all the way across is your opposite. And then right beside is your adjacent. Which side gives you nothing? Hypotenuse. Scratch that out. Forget about it. That leaves us with opposite and adjacent. So O and A, which only goes with TOA. T stands for tan of what you circled, so X. And it goes in order. O then A, O over A. So 36 over 18. We are looking for an angle, so we're going to do tan inverse of 36 over 18. Type that in your calculator just like you see it. tan inverse bracket 36 divided by 18, close bracket. And we'll go to the nearest one decimal place, 63.4 degrees. So to answer the question, she needs at least 63.4 degrees to actually touch the top of the tree. So realistically, she actually needs like a shade more than 63.4 degrees. She only hit her lob wedge at 55. So her lob wedge basically is less than 63.4. So that means that her lob wedge is like something like this. And it's going to strike the tree, since 55 degrees is less than 63.4. Word problem, therefore statement. Therefore, she will not clear the tree. As she needs at least 63.4 degrees and not 55 degrees. Hopefully that makes sense. Again, very simple conversion in that question. I'll give you the conversion if there's any kind of question like that on the test. Our next two, number 6, a lighthouse is 15 meters tall. A sailor in a sailboat looks up to the top of the lighthouse at an angle of elevation of 22. How far is the sailor from the base of the lighthouse? So we have a lighthouse, straight up and down. Got some water, got a boat, and we got a sailor looking up to the top. So this is going to make a triangle. Unless I've told you otherwise, anything that kind of meets the water, meets the ground, assume it's 90. I told you the lighthouse is 15 meters tall. Angle of elevation, remember, always goes up. So up off the water in this case, 22 degrees. And we want to know how far the sailor is from the base. So we're looking for that. You see 90, again, Sohcahtoa. Label your sides. So circle your reference angle, can't be 90. The other angle I gave you is 22. Across from the 90, hypotenuse, all the way across, opposite, right beside is adjacent. Which one gives you no information, so no side, no letter. Hypotenuse gives us nothing. So we have O and A, goes with TOA. T stands for tan of what you circled. Goes in order, O then A, 15 over X. So this is a good example because it has X on the bottom, and we haven't encountered that in a few lessons. So I still want to get X by itself, and off the bottom of the fraction, cross multiply. X tan 22 equals 15. And then you want to get the tan 22 away from the X. You're currently multiplying. How do you get rid of that? Divide both sides by tan 22. And X is going to equal, I'm going to use your calculator, 15 divided by tan 22. And we'll go to one decimal place, 37.1 and meters. Don't forget a therefore statement. Therefore this, and I don't have enough room. Therefore dot 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 dot. You fill in your own sentence. Therefore the sailor is 37.1 meters away. Number 7, to measure the distance across a river, a surveyor took measurements, drew the diagram, determine A to B. So really what we're looking for is side C. Now I don't see a 90, so Sohcahtoa is out the window. That means we're left to make our chart. Fill in all your side lengths. So C is what you're looking for. I don't know angle B. Angle C. Sorry, I wrote that question mark in the wrong spot. I'm looking for side C, not angle C. Angle C is 37. Angle A is 86. Don't know angle B. Don't know side A. Side B is 365. Then you ask yourself, do you have a complete letter? In this case, we do not. But before we try to jump ship to cosine law, ask yourself, do you have an easy way to get a letter? And the answer is yes, because we have two angles. So 180 minus 37 minus 86 will give us angle B. 180 minus 37 minus 86 gives us 57 degrees. So now we know angle B. And that's good because it completes letter B for us. So now the letter B is complete. That is our indicator to use sine law. And I'm looking for side C, so we'll start there. Over sine C, which is 37, equals what you drew the box around. 365 over sine 57. Get C by itself, cross multiply. C equals 365 sine 37 over sine 57. Type that in your calculator just like you see it, 365 sine 37 divided by sine 57. 261.9 meters. So the distance from A to B is 261.9 meters. I'll let you fill in the therefore statement on your own. Therefore, the distance from A to B is 261.9 meters. Number 8. The posts of a hockey goal are 1.8 meters apart. Lee is 4 meters from one post, 4.2 from the other. Within what angle must she shoot the puck to score the goal? And really this should say like if the net was empty, or like what angle does she have to shoot to actually hit the net. So we'll start off by drawing a diagram. So that's the goal line. There's some posts. We'll say there's Leah, L for Leah. We know that the posts are 1.8 meters apart. And for a test, doesn't matter where you label these. She's 4 meters from one, 4.2 meters from other. And we want to know angle L. What angle does she have to shoot within to hit the net or to score a goal on an empty net? So we could make our chart. However, we also know that whenever you have all three sides with no angles, and none of them are 90, you have to use cosine law. So we only have one choice. Cosine law for angles, in this case L. And if you remember the pattern, if I start with L as my angle, on the back end when I subtract, that's side L. So minus 1.8 squared. And then it's just going to be 4 squared plus 4.2 squared divided by 2 times 4 times 4.2. And again, if you're struggling with the formulas, you're going to get them all on your test. Basically, you're going to get them just like the formula that I gave you on this review. For this, you got to do it one step at a time. Do the top first, bottom second. 4 squared plus 4.2 squared minus 1.8 squared, 30.4. And then 2 times 4 times 4.2, 33.6. As I've been stressing all unit, don't just type in cos of that. You're looking for an angle, so it's cos inverse of 30.4 over 33.6. So shift cos 30.4 divided by 33.6, close bracket. And we'll go to 1 decimal place, 25.2 degrees. Therefore, Leah must shoot within 25.2 degrees to hit the net or score on an empty net. Now on to our last question of our review, and this is kind of like the quote-unquote hardest one, or at least the one that has the most work. So from the top of a 250-meter high cliff, the angles of depression of two boats on the water are 25 degrees and 50 degrees. How far apart are the two boats? So this one's a tough one to draw. Cliff, some water, one boat, and a second boat, and the cliff is 250 meters high, and they're looking down at both boats. We can assume that the cliff, unless otherwise told, is 90 with the water. So we basically got two triangles going on there. I'm going to color code them. So we have a big one on the outside. We'll call that the blue triangle. So I'll draw that over here, because sometimes it helps to draw them separately. And that's 250. And then we have a red triangle I'll use for this smaller one here. And I'll draw that one down here. Now our end game here is to figure out what that distance is, the distance between the two boats. So what I'm thinking we could do is we could find this whole length, which would be using the blue triangle, then find this length using the red triangle, and if we subtract those two, what's left over should be our distance between our two boats. What we don't have is we don't have any angles inside our triangles except for 90, and we know we can't use those. So we're going to have to use the other piece of information in the question, which was our two angles of depression. Now you have to remember, angle of depression goes down off the sight line, or down off the horizontal. So if we're looking, if you were on top of the cliff, looking straight across, and then you had to move your eyes down, there would be one angle to there, and another angle to there. Now I gave you 25 and 50. Looking at those two purple arrows I drew, hopefully everyone can figure out which one's the smaller angle, which would be this one, which would be 25 degrees. And then the bigger angle, which is this one, would be 50. So we're going to start with the blue triangle. We just calculated, or we just figured out that's 25. And to get this angle, you have two ways, going all the way back to the first lesson. Z pattern, or that also makes 90 up top. So if you did 90 minus 25, you get 65 degrees. Since it's 90, we know that we can use Sohcahtoa. And I want to find how far away the boat is from the cliff, so that's what I'm looking for. Circle your reference angle, label your sides, cross from the 90's hypotenuse, all the way across, opposite, right beside is adjacent. Which one gives you nothing? So no side length, and I'm not looking for it. Hypotenuse. So it leaves me with O and A, which is tan, or TOA. Tan of what I circled, 65, goes in order, O over A, X over 250, cross multiply, 250 tan 65 equals X. And we'll go to one decimal place, type it in like you see it. Hopefully you get 536.1 meters. So we know that this blue length is 536.1. Let's repeat the exact same process, but with our red triangle, the smaller one. So our angle of depression is actually bigger, which is 50. We know we can get this by doing 90 minus 50, or Z pattern down at the bottom. That's 40. I'm looking for how far away it is from the cliff, so that's my X. Circle your reference angle, which can't be 90. Label your sides. Hypotenuse, all the way across, opposite, right beside, adjacent. And which one gave us nothing? Hypotenuse. Since it's 90, we know we're using Sohcahtoa. Again, it's opposite adjacent, so that's TOA. T stands for tan. This time it's going to be tan 40, so not 65 this time. Tan 40 goes in order, O over A, X over 250, cross multiply, 250 tan 40 equals X. Type that in your calculator just like you see it. 250 tan 40. One decimal place, 209.8 meters equals. Sorry, I had a technical error there where it kicked me out of the video. So you're just going to continue what I write here where you left off with the example. So we had a big distance of 536.1. We had a smaller distance of 209.8, I believe. And we wanted to figure out what this was. So if I do 536.1 and I subtract 209.8, I get 326.3 meters. Don't forget word problem, therefore the boats are 326.3 meters apart. Whew. Now we can take a deep breath. So that was the toughest one, I think. And if you don't think it was tough, that's great. If you do, practice it some more. That's the end of our review. You have the rest of the day to perfect your skills. Remember, there's no cheat sheet, but I'm going to give you every single formula that you need laid out to you. Sohcahtoa, sine law, cosine law, Pythagorean theorem. You just have to know how to use those. So do lots of practice. Again, there's only 3 things that you guys have to know, and I'm sure you guys are going to do great on the test. Take your time. Don't leave any blanks. And you guys are going to do awesome. And if I don't happen to see you, which more than likely, given my circumstance, I'm not going to see you, have a great Christmas and a great Christmas break. A happy New Year. Stay healthy, stay safe, and I will see you all in the new year. And good luck on your test.